In this video, we will talk about the equivalent resistance. Resistors can be grouped in series like in figure 1. To find the equivalent resistance R in this case, we imagine replacing the two resistors of resistances R1 and R2 by a resistor of resistance R, like in figure 2, that neither change the voltage nor the current in the circuit. Applying Ohm's law in figure 2, we can write UAC equals RI, and in figure 1 we can write UAB equals R1I and UBC equals R2I. Then, applying the law of addition of voltages between A and C, we can write UAC equals UAB plus UBC. Then we replace each parameter by its expression and get Ri equals R1I plus R2I. We factorize by I, then we divide by I to cancel it in the obtained equation and get R equals R1 plus R2. In general, the equivalent resistance R of resistors in series is equal to the sum of all the resistances. Resistors can also be grouped in parallel like in figure 3. To find the equivalent resistance R in this case, we imagine replacing the two resistors of resistances R1 and R2 by a resistor of resistance R, like in figure 4, that neither change the voltage nor the current in the circuit. Applying Ohm's law in figure 4, we can write UAB equals RI. And in figure 3, we can write UAB equals R1I1 and UAB equals R2I2. Then, applying the law of addition of currents at A, we can write I equals I1 plus I2. Then we replace I by U over R to get UAB over R equals UAB over R1 plus UAB over R2. We factorize by UAB, then we divide by UAB to cancel it in the obtained equation and get 1 over R equals 1 over R1 plus 1 over R2. In general, the reciprocal of the equivalent resistance R of resistors in parallel is equal to the sum of the reciprocals of each resistance. Thank you for watching.